Hi. The idea of keeping fresh water tanks at home as decoration is very old, let's say a couple of thousands of years. But keeping marine tanks at home is much younger, and at the beginning it was only limited to the coastal areas. And no wonder, because in those days, due to the lack of knowledge about the chemical composition of water, only seawater had to be used. In today's understanding of this hobby, the first marine aquaria with the artificial seawater were set up, let's say, 100 years ago. But the first aquarists were facing serious problem. Every time they introduced fish to the newly set up aquarium, the fish died after a couple of days. When they replaced the dead fish with the new ones, they were living a bit longer, but eventually died after several days. Only the third or fourth group of fish was able to survive much longer. So the pioneers of the marine aquatics realized that introducing fish to newly set up marine aquarium almost always ended up with the death of the fish. But introducing fish to the tank that was set up 2 months earlier was giving them a big chance to survive. So what difference did the first couple of weeks make to the aquarium? Let's find out in the new episode of the Tropical Marine Power Vlog. Although first bacteria were observed in 17th century, the relevance to many natural biochemical processes was discovered only in the middle of 19th century. Nowadays it is obvious, but first aquarists had no clue about the role of bacteria in the biology and chemistry in our hobby. Let's go back to the first marine aquarists and their fish. As I've said, they had no clue about bacteria, but more importantly, they had no clue about the nitrogen cycle in the aquarium, which is one of the most important processes taking place in the fish tank. The whole secret of the dying fish was the toxicity of water caused by the fish themselves, because right at the start the water was not poisonous at all. Most of the fish and other animals living in water environment are ammonotelic, and this means that they excrete waste nitrogen in form of ammonia or ammonium ion. Both molecules are very similar, and in the marine aquarium, the equilibrium between them depends mainly on pH of the water. What is important here is that ammonia, NH3, is very toxic for all animals. In the typical marine aquarium, where pH is between 8 and 8.3, the majority of ammonia exists in the form of relatively safe ammonium ion, and only fraction exists in the form of extremely toxic ammonia. Unfortunately, ammonia is so toxic that concentration over 0.1 mg per liter is potentially dangerous for the inhabitants of the reef tank. And this was the main reason why the fish were dying so quickly in the newly set up aquarium. They were just getting poisoned with their own excrements that contained toxic ammonia. But why only a couple of weeks later the ammonia is not a problem anymore? After all, fish still excrete ammonia, right? Yes, but during that time, nitrogen bacteria began to multiply in the aquarium, and they are the main driver of the nitrogen cycle. You have probably heard already about the nitrogen cycle, but let me explain the basics so you get it right. As the nitrogen cycle is regularly studied, scientists are constantly discovering new processes and pathways occurring in it. So to make it simpler, I'll be talking about the conventional process. There are three main stages of the nitrogen cycle: nitrogen fixation, nitrification, and denitrification. The whole cycle is a mix of complex, multi-level reduction and oxidization reactions in presence of several sophisticated enzymes in bacterial cells membranes. But as I have promised earlier, I'm not going to go into the boring details, and I have got some props to explain it in a nice and easy way. Gaseous nitrogen, N2, accounts for over 78% of the air we breathe. However, in normal conditions, nitrogen is non-reactive gas and as such is unavailable for most of organisms. However, some bacteria species are able to convert it into ammonia. Majority of those processes takes place in the soil, outside of the marine environment. In marine aquaria, this process can be carried out by some cyanobacteria, but it doesn't contribute significantly to the nitrogen cycle itself. In the marine aquarium, The main source of nitrogen is the food provided by aquarists. It usually contains high concentration of proteins and amino acids, which are required for healthy growth of fish and invertebrates. But in result of many metabolic processes, part of this nitrogen is exerted in form of ammonia NH3 or ammonium ion NH4+. Nitrification is a two-step oxidation process of ammonia. And in very simple words, it is about adding atoms of oxygen to nitrogen. Ammonia and ammonium ion get oxidized to nitrites in the first step by strains of Nitrosomonas or Nitrosococcus bacteria. These bacteria use special enzymes to catalyze the process according to the equation 2NH4 plus 3O2 gives 2NO2 plus 2H2O and 4H plus. I have to mention that the intermediate product of this phase of nitrification is hydroxylamine, but I omitted to simplify the reaction. After this step we get nitrites, an oxidized form of nitrogen. It is still very toxic, so we want this to be quickly oxidized again by another bacteria from Nitrobacter strains. The chemical equation looks like this. 2 molecules of NO2 minus plus O2 gives 2 molecules of NO3 minus. But it is simply about adding another atom of oxygen to the molecule of nitrite, in result of which we get a molecule of nitrate. Concentration of nitrates below 50 mg per liter are not toxic for most of marine aquarium animals. And on top of that, many organisms, mainly bacteria and algae living in the marine aquarium, consume nitrates directly from water, which reduces their level. The nitrification is the main process that changes toxic ammonia into generally non-toxic nitrates. And this is the answer for the question asked in the intro. In an average marine aquarium, it takes a couple of weeks for the nitrogen bacteria to multiply and to be able to change ammonia into nitrates. I've just explained the role of nitrifying bacteria in the process of oxidation of toxic ammonia. But there are also denitrifying bacteria, and you can expect that they play a major role in another important part of the nitrogen cycle called denitrification. Although there is some demand for nitrates in the marine aquarium, their concentration can quickly go up beyond the safe level, and if not controlled, they can trigger an outbreak of nuisance hair algae. Luckily, the nature has given us the nitrifying Pseudomonas bacteria which live in anaerobic conditions, for example in the rocks or deeper in the sandbed. Because of the anaerobic conditions, they use nitrates instead of oxygen in the respiratory process. And by using special enzymes, they gradually reduce nitrates by removing atoms of oxygen from the molecule. As you can see, in every step there is less oxygen per atom of nitrogen. Nitrates reduces to nitrites, then to nitric oxide, then to nitrous oxide, and then to nitrogen. And what do we get at the end? The very same molecule of gaseous nitrogen N2 that gets released from the water into the air. This way, we have completed the nitrogen cycle with the denitrification pathway according to the equation 2 molecules of nitrates plus 10 electrons plus 12 protons gives 1 molecule of nitrogen plus 6 molecules of water. It is important to remember that in the marine aquarium, the whole nitrogen cycle takes place in 2 zones. The nitrification part takes place in water column and everywhere where bacteria have access to oxygen. For example, on the rocks, in the shallow layer of the sand or on the glass. The deeper we go into the rocks or into the sand, the less oxygen is available. Therefore, in those zones, the nitrification gets replaced by the denitrification. In this way, there is no competition between different strains of bacteria. Let's summarize what we've learned so far. The nitrogen cycle is one of the most important processes in the biosphere and even in the whole marine aquarium. It plays a major role in chemical stabilization of the fish tank. Each of the 3 main processes are performed by different types of bacteria. In nitrogen fixation, we have azotobacter and rhizobium, and the process takes place usually in the soil. In the nitrification, we have Nitrosomonas, Nitrosococcus and Nitrobacter in the aerobic zones of aquarium. And in the denitrification, we have Pseudomonas in the anaerobic zones of aquarium. The parts of the cycle that take place in aquarium require healthy strains of bacteria. In the newly set up aquarium, there is very little of them, and they need time to grow and multiply in order to drive their cycle effectively. Obviously, they will get into the aquarium with live rocks, live sand, coral frogs, etc. But it is also a good idea to buy ready-made bacteria mixes from the local fish shops to facilitate the cycling of the new aquarium. In mature tanks, there are also situations when the performance of the existing bacteria is lower than it should be. It usually happens when the aquaria are exposed to sudden accidental changes, for example in salinity or temperature. But also when aquariums add things like antibiotics or ozone. So adding the mix of nitrifying or denitrifying bacteria is in those cases also a good idea. So this is it for today. I realized that this episode was long and seemed complicated, but understanding the nitrogen cycle is very important to achieve satisfaction in this hobby. All viewers who take the passion for marine aquarium seriously, I strongly encourage to subscribe to this channel. In future we plan to shoot more detailed episodes like this one. Thank you for watching and see you soon.